Okay, let's get started. Let me share the screen. All right, here is the schedule. So today we will continue on ship design procedure. And then we continue on hull form definition if we have time. And today's discussion will be led by Changwo Gang, Chunggu Gang. Right, Chunggu Gang. Okay. So I should Any question on schedule? No. Then we will move on to where we stopped last time about engineering economics. Okay. So it is very similar to bank operation. When you go onto your account, say there is a different kind of account, monthly depositing, or big money can be depositing. So we can say deposit account usually earns interest. So that is a similar calculation. We need to think about this. That the present money, $100 today or 1 year after, $110, which one is better for you? The kind of thing we need to calculate. Okay. So cash flow and discounted cumulative cash flows and value of the cash flow. So if we start, say, minus 100,000, say, dollar can be invested at the beginning, and then say you open a shop or you buy a truck, so that operating a truck to earn money. Then monthly revenue or income can be here. You say 25,000. Looks like. And then how many months you need to recover the original investment? Looks like 5 months or 4 months or 5 months. Number 5. But that is not true, because we should think about interest during that period, so that the yellow curve should be the real. Because if we loan the initial invest money of $100,000 from the bank, you should pay also the interest to the bank, so that the realistic calculation can be 6.5 months or years probably. You recover your starting your own starting investment money. After that, you can has a profit out of your investment. That is the calculation. We need to have a present money and future money. So what a simple case for the shipbuilding or ship operation. Here is the crude oil carrier, ship which carries crude oil between Persian Gulf and Busan port of Korea. There are a lot of operation there because Korea imported all the oil because we don't have any production. And then the predict future freight rate. Freight rate is money, the ticket money or cargo handling money. Say if you operating your truck for traveling between Daejeon and Seoul, how much money you charge to your guest or customer, that can be a freight rate. But it can be fluctuating between the situation. So prediction of future income is not easy. So instead, they choose to use a required freight rate. So that can be a minimum income we need to earn, not to lose my money. So minimum money can be, this citation is RFR is a short name of required freight rate. And AAEC is the average annual cost. And then divided by cargo capacity. Say your truck is, say, loading capacity is 1 ton of cargo. Then the cargo capacity can be 1 ton, 1,000 kilogram. Then you should know, also expect that average annual cost. Annual cost can be largely the oil price or gasoline price or diesel oil price. That is the about more than 30%. And then your own your wage, your salary, and then there are tax and insurance and toll fees for the expressways and other things. There's some maintenance, repairing. So altogether, we call this is an annual cost, an average annual cost divided by 1 ton or 1,000 kilogram. Then you may also calculate minimum payment or carriage of transportation of, say, per kilogram. That can be the minimum freight rate. So that is the required freight rate. When you design a ship, the implication is saying that best ship in any given trade is the one that can be offered minimum rate while still producing reasonable profit. So when you're calculating AAC here, you need to also include some small amount of profit of your starting investment. Right. Now, this is a Baltic Dry Index. Baltic is sea, I guess, is north west Europe somewhere. Is sea name is, ocean name is Baltic. And there has a dry cargo, dry bulk carrier, has an index similar to a stock market index. So this looks like a freight rate index. Index is a direct cost, but not dollar, but similar to your stock market index. That is not won or dollar, but they have just the numbers, right? Well, here you see that this is starting from January 85 up to 2015 January. So span of a year is 30 years. During that time, maximum and minimum has 17 times fluctuation. Very big fluctuation. If you think about your travel cost or air flight or train price or highway bus trip or even the taxi price, the fluctuation is not so high, not doubling within say Oh, this is 30 years. It can be doubling, but not as much as 17 times of fluctuation. That's why it is not easy for shipbuilding or shipping operation companies. Right. So there is another type of economic criteria in addition to RFR. RFR is at the bottom left of this table. So there are other criteria. Looks like from the top is NPV, net present value, and DCF, discounted cash flow rate of return. AAC is average annual cost or life cycle cost. And RFR is required for the rate. So top one is easy to understand, net present value. See, when you see this kind of business like this one, and if you think about this kind of business, say you operating a ship or you're operating a truck, after 10 years, you see that there is a profit amount of 50,000, right? So by calculating back to this money after 10 years, what can be the net present value of this money profit? Can be less than 50,000 because of the discount rate. Anyway, that is, we can say, net present value, not future value, present money. Okay? So after calculating all the fluctuation, incoming and outcoming, outcome, you can calculate, if you know the exact cash flow for 10 years, you can calculate net present money. But that is not the case, because you need to know there is a necessary input there at the right column. Annual revenue is the most important. How much money you can get from the business. That is not easy. Say you are thinking of operating a restaurant, then how much money you will get from the restaurant within 1 year? You cannot predict, right? Annual revenue is very stable, unstable, fluctuating. And then annual operating cost is pretty much expectable. And also minimum acceptance rate of interest. Rate of interest is a bank interest rate. So NPV is easy to understand, but it is not easy to calculate. And discounted cash flow is similar. Still, there is a annual revenue should be known. The minimum interest rate is not required. And AAC is a part of RFR. It is already explained. Here, there is two more terminologies, say CAPEX and OPEX. At the bottom, I write down capital expenditure and operational expenditure. We come back to the truck business operation. If you buy your truck at the beginning, you should pay, say, $20,000 or more. That can be the capital expenditure at the beginning. And there will be more, something like registration fee and then tax and insurance. The other things are operational expenditure, repair, insurance, and mainly the oil price, gasoline or diesel. But that is every day or every week, you need to put operational expenditure. CAPEX is big money at the beginning. So coming together, so AAC, the annual cost is made of capital expenditure and operational expenditure. Summary, engineering economics, the decision should be based on science and art or experience. So we need to have a statistics because we cannot have a future values of income. So what can be the possibility of income, right? And it is important to understand how economics can be used to help make good decision in ship design. So as an engineer, you need to know about economics. Otherwise, your design will be bad. So every engineer should know about some of the economics, not all of them. Some actually, at minimum, engineering economics is an important topic for engineers and especially for designers. So design environment, we need to think about the market. What market is moving to big ship or smaller ship, faster ship or lower ship, environmentally friendly or not, that kind of thing. Government policies going together with this trend and regulations. And also there is not only domestic one, there is international regulations such as pollution and environmental, MARPOL, marine pollution, and double hull tanker rule is something like a SOLAS. SOLAS is a short name of Convention for the Safety of the Life at the Sea. SOLAS. Safety of the life at sea. That's a short name. Safety of the life at sea. Right. And that is made happen. They created this rule because of the Titanic accident in early 20th century. So 70 years is the happening, but this is a revised version. So at this moment, this is the current version of 74 is the current version of SOLAS. So first version can be made around 1915 something, because the accident was early 1900. And equipment vendor means the manufacturer of equipment, because ship is very big and there are so many machines inside of ship. The machines should be purchased to build the ship. Say cruise ship or battleship and ocean plant, the inside machinery installation or equipment is very different. So that who is making, who is supplying that kind of equipment is important environment for the designers. So designers should know well about these, who produce the best engine or motor or pump or boiler around the world, or cheap and high quality. And also ship owner preference. There are very special ship owners who prefer something yellow, something high speed. Depending on the person or company, they have their own special preference. So designers should know about this. And management organization who will operate the ship. Because say I have a building, if I have a building, I will be the building owner, but it is too big for operating, complicated. So I hire another company only for the operation of this, or management of this building. So that is another organization that is doing another business. And ship is similar. And MARPOL is a marine pollution. And you see that we are now in 2020 year. And then sulfur is a chemical percentage, should be lower down very drastically, much big difference in 2020. So that the designer of the ship should know about this kind of changes, so that you need to know how much pollution is coming from your design. So you should select well what kind of engine, what kind of devices should be used for them. You can think about your car, your truck. How can you reduce your sulfur pollution? coming out of your car. That is similar. Now it is an aircraft carrier. So there is floors and hangar deck and something like that. And so if you're designing to this kind of ship as a designer, what is the environment surrounding this design? Correct. Question. No question? Then we may go on to second presentation by Zulfikar.
Hello, can everyone hear me?
Yes.
Yes.
Okay, so can you wait a second? I'll close off then. Okay, good morning, everyone. Today I'll be presenting on the ship design procedures, which will help you to design your very own ship in the future, hopefully. So first of all, I will talk about the major design participants. So firstly, construction and production planning, the participants. So a ship is made up of many parts, as you know, and so we have to plan the constructing and assembling of each of them. And so the assembly is like welding procedure, so it takes a lot of time. So all of this